So now we're working with inverse trig, and we're doing integration problems. So on our inverse trig with our integration problems, we're starting with example 3 because we already did the differentiation problems in the previous video. So now, if you remember with the integration, when I was doing the content video, there are really only 3 basic integration problems that the AP exam focuses on. And they are arcsine, arctan, and arcsecant. And so we just got to be able to pick, if we look at a particular problem, we just need to decide, is this arcsine, is it arctangent, or is it arcsecant? And if you remember the difference between them, arctan is the easiest to remember. It has no radicals. So obviously this one's not arctan. This one over here is probably arctan. So this one, I'm going to already make a note that this one's arctan. All right, so then we've got to decide, is this one the sine or the secant? And the difference between the sine and the secant is the secant has an extra thing on the outside of the radical, and it also starts with your function squared. So since this starts with the number squared, this one's going to be the arcsine. All right, so what is the rule for the arcsine? All right, we need to make it look like 1 over the square root of a squared minus u squared, and then the du. Okay, so that's what it should look like. And then the answer will end up being arc sine u over a plus c. Okay, so I'll erase that. We'll remember that. Okay, so this is what we're trying to do. So when I compare this, I need to figure out what is my a, what is my u, and what is my du. Okay, so those are the 3 things I need to figure out. Okay, so first of all here, when I'm comparing what I have to the arcsine formula, it looks all the same. A squared, so if this is a squared, then a's got to be 2. And if this is minus my u squared, if this is u squared, then u has to be my x, which means du has to equal dx. And so when du equals dx, it is a straightforward, flat out rule. Okay, it is straight up this rule. So my answer is going to be the arcsine of the u over the a. So my u is my x, my a is 2, and then plus c. So whenever you see that the du equals the dx, it is a straight up simple rule. Okay, now let's do this one. It's arctan. All right, so we know this is arctan because it doesn't have a radical in it. Okay, so let's look at what arctan is. So the arctan is, I like to keep the du on the outside, so it's 1 over a squared plus u squared du, and then that equals the 1 over a arctan of u over a plus the c. So this is the formula that you would be looking at to compare this to. So when I'm looking at this, I need to figure out what is my a value, what is my u, and then what is my du. Okay? So again, if du ends up equaling just straight up dx, it's simple formula. Okay? If it's not, we got to do a little work. All right, so for this problem, I'm looking here and comparing it to what we have. So if I compare what I have to this rule up here, the a squared has to be 2, so that means a is the square root of 2. The u squared is the 9x squared, so that means u has to be 3x. And so now when I look at this, I'm going to take the derivative, so du equals a 3 dx. So then dx equals du divided by 3. I'm dividing by 3 just like I would with a normal u substitution. So I'm going to convert this using the substitutions now. So this is 1 over, this will be the square root of 2 squared plus, and then this will be my u squared. And then in place of the dx, I'm going to put du over 3. So you notice the only thing I have extra is that little 1/3. So that's really the only thing that's extra is the 1/3. So then I can compare it to the rule now. So this is the a squared plus the u squared. The only thing extra I have is the 1/3 coefficient. So when I do the antiderivative, it's going to be 1/3 times this stuff here, which I can still put my plus c on the outside. So I'm going to do that. I'll put that there and put the plus c on the outside. So it's still going to be 1 over a, and my a is radical 2, arctan of u over a, and my u is 3x over the a radical 2. So the final answer is going to be 1 over 3 radical 2. You could rationalize that if you wanted to. And then arctan, and then 3x over radical 2, and then your plus c. So this is your final answer. Now again, like I say, you can rationalize this if you want to, but you don't have to. So what I did is if my du equals my dx, if that's straight up equals, then it is straight up substitution into the rule. If my du doesn't equal dx, and then when you solve for dx, you're just going to end up having an extra coefficient, and then you can just pull that coefficient out, and then it's a straight up rule. Okay, it's following the rule. So these aren't that bad. You just have to know the rules. And I'll be honest, I don't have these totally memorized. I just know them well enough that when I do the multiple choice on the AP exam, I can match up which one it is. All right, so I know enough to know the patterns. All right, so like for this one has an x on the outside. It also has the x squared or the u squared function front. So I know this is an arc-secant problem. So when I'm looking at the arc-secant problem, I'm looking at the integral of 1 over my u, and then the square root of u squared minus a squared, and then it is du. And this equals the answer 1 over a arcsecant of the absolute value of u over a plus c. So there's the rule that I'm matching up with. So I just need to figure out my pieces. All right, so I need to figure out what a is and what u is, and then figure out the du. Okay, so my a value on this is minus a squared. So this is minus a squared. So that means that a is 3. And then my u is, the u is in the front, and then the u is here with the squared quantity. So u squared is in here. So that means u has to be 2x. All right. So then I'm going to take the derivative here. So du equals 2 dx. So dx equals du over 2. Okay? All right, so when I trade this out, I'm going to have 1 over, right here, this x needs to be replaced with a u. So you will notice here, I have x, 2x equals u. So I need to replace this x with u divided by 2. So this is going to be u divided by 2, square root. This is going to be my u squared. So this would be u squared minus, and then the 3 squared will be minus my a squared. So I'm just matching it up to the rule, just trying to get everything to match just perfect. And then my dx is going to be a 1/2 du. All right, so let's clean this up a little bit. I've got 1 over, you'll notice this 1/2 is going to cancel with the 1/2 right here. So that's just going to leave me with a u, and then the square root of u squared minus a squared du, which voila, that is perfect with this formula right here with exactly what I have. All right, so my antiderivative is going to be 1 over my a, which my a is 3, and then arcsecant, and then I've got my absolute value of u, which u is my 2x, over my a, which is 3, and then add the c. So you'll notice when I found my a and my u and my du, and I took my derivative to find my du, and then I solve for dx. And then I'm replacing everything to get it to match this rule up here just perfectly. So when I did that, I had to replace this x right here by solving for x, which is u divided by 2. So I replaced my x with that, and then I put in the u here, put in the a here, because that's a squared, that's u squared. And then when I put in the dx was 1/2 du, that made this 1/2 cancel with this 1/2 here. And so that left me with just u in the bottom, which made it match perfectly with the rule. So everything turned out just perfect. Once I substituted and canceled, I was able to get the rule to match beautifully. Okay. All right, let's try this one. This one's just slightly a little bit different. We'll just see here. Okay, so looking at this one looks like what at first? Well, I notice I have my u squared first. If u squared is first, then that means it needs to be an arcsecant. But I don't have the term on the outside. So we're going to have to see what's going to happen with that, and we'll see here in a minute. So what is the arcsecant rule? So the arcsecant rule is the 1 over u, and that's the one that seems to be missing out here. And then it's the square root of my u squared minus my a squared, and then my du. And that's going to end up equaling 1 over a arcsecant of the absolute value of u over a plus c. So all I am doing is writing out the rule. All right. So what I need to do is I need to figure out what is my a and what is my u, and then find the du. All right, so let's do that. So my a is the minus a squared. So minus, that'd be 1 squared. So a is 1. All right, my u is the term here that's squared in the front. So what is being squared here in the front to get e to the 2x? Well, that's going to be e to the x. All right, so let me just point out here. If you have e to the x squared, when you raise a power to a power, you multiply your exponents, and so that's e to the 2x, just to refresh your memory with that. So when you raise a power to a power, you multiply your exponents. So e to the x squared is e to the 2x. So I just want to remind you of that. I can leave that there. So this is just something to remember, make sure. All right, and so here u squared, to get e to the 2x, I'm squaring e to the x. So that means my u is e to the x. So now I'm going to do the du. So the derivative of u is du, the derivative of e to the x is e to the x dx, and then remember solve for dx. So that means I'm going to divide my du by e to the x. And so now I'm ready to trade out, to try to get what my equation I have here to match the rule. All right, so this is going to be 1 over, in place of this, I'm going to have u squared, because my u is e to the x, and it's being squared, minus, and then a is 1, so that's going to be a squared, all right? And then in place of the dx, I'm going to put du over e to the x. Well, voila, there's that e to the x that I'm missing in the front right here. It comes from my dx substitution. So when I replace the dx with du over e to the x, here's my term e to the x, which is my u, which is going to be the part that goes right here, the u that's going to go right in front. So that term is actually there. So this matches perfectly with the rule, because the du over e to the e to the x is my u, so that puts a u value in the denominator, which was missing originally. So it really is there from the du. So this matches up perfect. So my answer is going to be 1 over a. So my a is a 1, so that's 1 over 1. Arcsecant of the absolute value of u is e to the x, which doesn't need bars because e to the x is never negative. And then over a, which is 1, plus c. So really, this is just arcsecant of e to the x plus c. All right, so that's all it is. Good, good, good. All right, number 6. So you notice these aren't really that bad. You just have to know the rules. All right, number 6. Same thing, same thing. The only thing we're going to have to do here is we're going to have to split this up, because notice there are 2 terms in the numerator. So I'm going to split this up into 2 separate integrals. I'm going to have x divided by the square root of 4 minus x squared dx, plus the integral of 2 divided by the square root of 4 minus x squared dx. So I'm just breaking that up into 2 parts, because my numerator has two parts. So I'm going to think of this as the sum of two fractions with the same denominator and break it up into two separate integrals. All right, this first one is a regular u sub. All right, this is a regular u substitution on this one. This one is going to be your arc sine, okay, because it's got the a squared minus the u squared. So this is going to be an arc sine. This is going to be a straightforward u sub. So we're actually doing 2 in 1, okay? All right, so let's do our u sub first. Most people don't have any trouble with our u sub. All right, so to do my u substitution here, I always usually do green. I'm going to let u squared be 4 minus x squared. So 2u du is going to be what? A negative 2, sorry about that, negative 2x dx. So then dx is going to equal 2u du divided by a negative 2x, and so those 2's are going to cancel there. We won't need those. So let's trade this first part out, okay, and do this first part u substitution. So this is going to be an x over the square root of u squared, and in place of dx, I'm putting a u du divided by negative x. So that's divided by negative x. Notice my x's cancel, which is beautiful. All right, so the x's cancel. So when I'm putting this in order, like I've taught you how to do, it's going to be a negative 1 because I have a negative sign, but 1 is my coefficient. And then with my u's, what have I got going on here? This is a square root of u squared, so that's u, and it's in the denominator, and it's going to cancel with this u that's in the numerator. So because I have it in the denominator and in the numerator, they cancel, okay? So the u term is gone, so all I'm left is a negative 1 du is all we got. Look at that, look at that. All right, so then I'm doing the antiderivative. So the antiderivative of negative 1 in terms of u's is a negative u, and we'll put the plus c at the end when we're done. All right, so this is negative u, and so I'm going to end up putting my u back in. So if I go back over here, u squared was 4 minus x squared. So that means when you take the square root, u is going to be the square root of 4 minus x squared. So my answer is negative u. So my answer is going to be negative the square root of 4 minus x squared. So that's the first part. All right. Now I've got to add to that my answer I get from this part. So now I got to think about the arc sine situation part. Okay. So for your arc sine situation, let's see, I'll use pink for that. With arc sine, let's think about the rule, okay? So over here, I'm going to write down the rule for arc sine. It is 1 over the square root of a squared minus u squared du, and that equals the arc sine of u over a plus c. So this is the rule that you would be looking at since you're comparing this, and it's a squared minus u squared, the function's in the back. So whenever the function's in the back of the radical, you know it's going to be arc sine. So this is the rule I should be comparing this part to, okay? So when I do that, I need to think, okay, who is my a, who is my u, and who is my du? I need to think of those three things, okay, since I believe this is an inverse trig problem. And it is an inverse trig problem. All right, so when I'm looking at this, my a comes from the a squared in the front. So here, a squared in the front. So a squared, that means a is going to be 2. Minus my u squared, so whatever term is in the back being squared, so that's minus x squared. So that means the u is an x. So that means du equals dx. So it's going to be straightforward rule, okay? Straightforward rule. However, I have an extra number here. So if I were to take this out and put a 2 in front, and this is 1 over, then this is going to match perfect with the rule, right? With a being the 2, and with a being the 2, and the u being the x. So I just had this extra coefficient of 2. So that means this is going to be 2 times straightforward rule, and then plus c on everything. So what is the straightforward rule for arc sine? It's just the arc sine of the u over the a. So that'd be the u over the a, so x over 2, and then your plus c. All right, so then I'm going to add that to my original answer down here. So I'm going to put back red, so that'll be plus 2 arc sine of x over 2 plus c. And you can't distribute this into this angle or anything. All right, it is totally just, you just have to leave that value out. All right, so again, what I was saying is you cannot multiply this 2 across and distribute it in here. No, don't do that. This is the coefficient on your arc sine, and it's the u over the a. All right. And so that is totally done there. All righty, so that problem's done. We got a plus c. All right, so again, we split that one up into 2 parts. And so our entire answer is this whole thing. So this is the part from the first part where we had the u sub situation going on, and then the second part was our arc sine, and then we have our plus c. So that's our entire answer because we split that up into 2 parts. All right, last problem. I wanted to do at least one where we have limits of integration, okay? So we've got one where we have to at least figure out the answer, which would be the area under the curve, right? So this is going to be the area under this curve between radical 3 and 3, right? So we're going to find the area. So we have to figure out what this is. Well, 1 over 9 plus x squared, oh, looking at that, that is a tan because it doesn't have a radical on it. So this is the arctan, right? So what is the rule for arctan? Well, that one looks like this. It's 1 over a squared plus u squared du. And the answer is going to be 1 over a arctan of u over a plus c. All right, so that's our rule. So when you look and you compare it to this, we can figure out everything just beautifully. All right, so what is our a value, and what is our u value, and what is our du? All right, so when we compare these, our a value here, well, a is a squared, so that's 9, so that means a is going to be 3. And then we've got our u squared in the back, so plus u squared, so that means the u has to be the x. So then du equals dx. Ooh, beautiful. That means it's straight up rule. And I do have a 1 in the numerator, so I don't have an extra coefficient or anything. So it matches perfectly. 1 over 3 squared, because that's my a, plus x squared, because my u is x. And so now I'm just able to straight up put this in this rule. So the antiderivative is 1 over a, so 1 over 3. Arctan of u over a, so that would be x over 3. And we don't need the plus c because we're going to evaluate from radical 3 to 3. All right, so now we're ready to do the fundamental theorem of calculus. All right, so let's get that rolling. Let's get ourselves enough room. So now we're going to do, I have to do it, fundamental theorem of calculus. I have to do it right, right? Okay, so we're going to plug these in. So you plug the top number in first. So this will be 1/3 the arctan, and you're putting a 3 in, so that'd be 3 over 3. Minus, now put the bottom number in, 1/3 arctan, putting in radical 3, so that's radical 3 over 3. Okay? So now we just have to evaluate. So 3 over 3 is 1, so this is the arctan of 1. So what is that asking for when it's asking for the arctan of 1? Well, it's asking for on the unit circle. Which ordered pair on the unit circle, when you do the tangent, gives you a value of 1? And remember, tangent is when you're doing y over x. You're dividing the y coordinate by the x coordinate. So we're looking for what angle on the unit circle, what radian degree, gives us a tangent value of 1, which is where, and the only way to get 1 is if your x and y coordinate are the same. Well, that's going to be the middle of the first quadrant, right? Where you're at radical 2 over 2, comma, radical 2 over 2. So that ordered pair, when you do y over x, which is sine over cosine, that's the tangent, right? That gives you an answer of 1. So when it asks for the arctan of 1, it's wanting you to tell it what radian measure on the unit circle gives you that answer. So what radian measure is this in the middle of the first quadrant from 0 to pi over 2? Well, that's pi over 4. So our answer is 1/3 times pi over 4. Minus, and now we got 1/3 times what answer we're going to get for this one. All right, so now we got to think, where on the unit circle do you get a tangent? When you calculate the tangent, you get an answer of radical 3 over 3. Okay, so that's what we need to figure out. Where do you get the answer radical 3 over 3? Now remember, tangent is when you do the sine divided by the cosine, which is the y-coordinate divided by the x-coordinate. So how are we going to get a radical 3 in there? Well, it's going to take, let me write some scratch work on the side. It's going to take doing one of the ones that has the radical 3 in it, right? So the two ordered pairs that have the radical 3's in it is the one that's 1/2 radical 3 over 2, or it's radical 3 over 2, radical 3 over 2 1/2, right? Those are your two other ordered pairs on the unit circle, barring the positive and negative aspect of it. But so in the middle is always the radical 2's, and then the first one here is over a lot, radical 3 over 2, and up a little, 1/2. The one here at pi over 3 is over a little, 1/2, and up a lot, which is your radical 3 over 2. All right, so this one is your pi over 3, and this one is your pi over 6, where you're over a lot and up a little. Okay, so now, which one is it? Which one of these is going to give us an answer of radical 3 over 2 when you do the tangent, when you calculate the tangent? So tangent is the y-coordinate divided by the x-coordinate, right? Sine divided by cosine. So if I do radical 3 over 2 divided by 1/2, which would be my y-coordinate divided by x-coordinate, the 2's are going to cancel, and that's going to give us an answer of radical 3. Well, that one ain't it. Okay, so let's do this one. So I'm going to do my y-coordinate divided by my x-coordinate. So the 2's are going to cancel. So that's going to give us 1 over radical 3. And when you rationalize this, you get radical 3 over 3. So this is the winner. So this is the one that gives me the answer, radical 3 over 3 on the unit circle. So that's pi over 6 right here, where you go over a lot and up a little. So that's radical 3 over 2, comma, 1/2. So when you do the tangent at pi over 6, you get the answer, radical 3 over 3. So when this is asking me on the unit circle, what radian measure gives me a tangent of radical 3 over 3? So that answer is going to be pi over 6. All right? So 1/3 pi over 4 minus 1/3 times pi over 6. So now I'm just calculating this answer. So this is going to give me pi over 12 minus pi over 18. So now I'm just going to find a common denominator. I'll do 36. So I'm multiplying this by 3. I'm multiplying this by 2. And so now when I subtract 3 pi over 36 minus 2 pi over 36 is going to be a 1 pi over 36. So there's my answer, pi over 36. All right. And then, of course, you can always double check that answer by math 9, right? If you take this right here and math 9, you can just type directly in the integral, and it's going to give you a decimal answer. So then when you type in your calculator pi divided by 36, it should give you the exact same decimal answer. Okay, to check your work, because you need to know how to do them by hand as well as math 9 and everything. So you need to make sure that you're able to do the antiderivative. And like I say, these are not real popular questions on the AP exam. There's only the 3 that you have to learn for integration that you need to be able to recognize. The arctan is a real popular one. It's the one that doesn't have the radical in it. It's not a hard one. 1 over a, arctan u over a. So as long as you can recognize them, then it's only 1 or 2 questions on the test. All right. So to practice so that you can get a little bit familiar with these in preparation for the AP exam, there are 4 for taking derivatives and there are 3 for integrating, because I believe that's how it's split up. The first part is derivatives, second part is integration. So there's your problems to practice and do, and then we'll see if you have any questions, all right, when we're together. All right, good luck.